Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. In this video, I will be going over the Chapter 21 math handout, problem number 2. If you need any setup instructions, please view the Chapter 21 math handout instructions and overview video. I will leave a link in the comments. Alright, looking at problem number 2 here, we get our values from number 2 on the math handout, and that tells me that I have 120 volts. I have a 10 to 1 step down ratio. Here we see 10 to 1. And I have 12 ohms of resistance. So I'll add that value up here. And I'm going to follow the steps that go along with my formula sheet. So the first thing I want to do, step number 1, is I want to find the voltage of my secondary. Now I have a 10 to 1 step down ratio, so I know my voltage of my secondary is going to be way less than the voltage of my primary. I actually could do this one in my head. If it's a 10 to 1 step down and I got 120 volts on my primary, it's going to be 12 volts on my secondary. But let's do the math just to demonstrate everything. So my formula tells me here that the number of windings of the secondary goes on top, then the primary windings times the voltage of the primary. So that's going to be a 1 over 10 times the 120, which equals 12. Let me do it on my calculator. So the first thing that goes in is the number of windings of my secondary, number 1. I hit over under. The next thing that goes in is the windings of my primary, that's 10. Scroll over times the voltage of my primary, which is 120 volts, giving me 12 volts in my secondary. Alright, my next step right here, I want to find the current of my secondary. And of course I've got the steps written here as well. So now we're on step number 2, and we're just going to use Ohm's law. Very simple. We just calculated the voltage of the secondary, which is 12 volts. And all I got to do is hit divide and then enter the resistance here of the load, which is 12 ohms, giving me so I had 12 volts, and I divide that by 12 ohms, and that gives me 1 amp. That is the current of my secondary. And you can see that right here. Alright, my third step is I need the power of my secondary. I'm going to use my power formula, Watt's law, for that. We see here that the power of the secondary is equal to the current of the secondary times the voltage of the secondary. The current of the secondary is already in my calculator, so all I got to do is hit times the voltage of my secondary, which is 12 volts, equals, and this tells me that the power of my secondary is 12 watts. Alright, next I need the power of my primary, which is equal to the power of my secondary. There's no calculation there. They're both 12 watts. Next, I want to find the power of my primary, and I'm going to use Watt's law for that. So I take my 12 watts already in my calculator, divided by the 120 volts of my primary. IP is equal to PP over VP, so I say divided by 120 volts, which equals 100 milliamps. That's the power of my primary. Alright, the last calculation that I need to make is my RL. And if we look at our formula sheet and we look at formula number 6 right here, ZP is equal to VP over IP. And my IP is 100 milliamps. So my VP is 120 volts over my IP, which I just calculated to be 100 milliamps. 100 times 10 to the negative third equals, and that tells me that the impedance of my primary is 1.2 k ohms. So we completed this step. As I said before, we can use this formula also to find the impedance of the primary, but right now we're just going to use the simple Ohm's law formula. If you've enjoyed this video and found it helpful, please leave a comment below.